Today we're going to look at multiplying binomial expressions, which is very similar to partial products, which you learned when you were in 4th, 5th grade. It's why I like using partial products, is because it scales up to this. We're going to start with two binomials, x plus 4 and x plus 7, and we're going to multiply those together. First, we're going to multiply the second binomial by the first term in the first binomial using our distributive property. So we have x times x and 4 times x. Then we're going to multiply the second binomial by the second term in our first binomial. We have 7 times x and 7 times 4. Next, we're going to simplify a little bit. X times x is x to the second power, or x squared. 4 times x is 4x. 7 times x is 7x. And 7 times 4 is 28. Once I do that, I combine my like terms. There's only one x squared, so that carries over. There's only one 28, so that also carries over. But there are two x terms, 4x and 7x. Those combined become 11x. So, x times 7 plus x plus 4 equals x squared plus 11x plus 28. We just multiplied two binomials when we were adding, but what happens if we're subtracting? We're going to do the next one, x minus 3 times x minus 4. Just like last time, I'm going to multiply the first term of the first binomial by the two terms in the second binomial using the distributive property. X times x is x to the second power, and x times negative 4 is the same as negative 4 times x. Then I'm going to multiply the second term of the first binomial by both terms of the second binomial. Negative 3 times x is negative 3x, and negative 3 times negative 4 is positive 12. Keeping track of our signs is absolutely vital in problems like this. We end up with x to the second minus 4x minus 3x plus 12. Notice how we have negative signs in the variable terms, but positive signs for both the x squared and for the digit at the end. Next we combine our like terms. X squared is its own term, 12 is its own term. What we're left with is negative 4x minus 3x. Negative 4 minus 3 is negative 7, so negative 4x minus 3x is negative 7x. We end up with x squared minus 7x plus 12. For our next example, we're going to look at what happens when we have terms with a coefficient, variable terms with a coefficient, and also what happens when we have a negative sign and a positive sign in our two different binomials, subtraction and addition. So we have 3x minus 5 times 2x plus 7. So next I'm going to take the first term of the first binomial and multiply it by the second binomial using the distributive property. 3x times 2x and 3x times 7. Then I'll take the second term of the first binomial and do the same thing. Negative 5 times 2x and negative 5 times 7. 3x times 2x is 6x to the second power. 3x times 7 is 21x. Negative 5 times 2x is negative 10x. And negative 5 times 7 is negative 35. Next, I say that plus a negative is the same as subtraction. So 6x to the second power plus 21x minus 10x minus 35. Next, I combine my like terms. 6x squared is its own term. Minus 35 is its own term. 21x and 10x are like terms, so I'm going to combine them. But 10 is negative, so it's 21x minus 10x, which is 11x. Our end result of the multiplication we started is 6x to the second power, 6x squared, plus 11x minus 35. Notice how in this expression we have a negative constant, and the middle term could be either positive or negative. If both of the binomials are adding, then both the middle term and the constant will be positive. I'm always assuming that the first term is positive. If 1 is positive and 1 is negative, the constant will be negative, but the middle term could be either positive or negative. If both binomials are subtracting and the first term is positive, then the constant will also be positive, but the middle term will be negative.